everybody. All right, so today we're talking about horizontal transformations. This time we're moving left and right instead of up and down. Okay, so our transformation form, we have y equals a times bx minus c squared, or all squared, plus d. Today we're focusing on the minus c part, okay? So this tells us left and right. And actually, because it's inside the parentheses with the x, if you will remember, oh gosh, did we do this with linear? I don't remember. I know we talked about it briefly with linear. I don't know if we went into, I don't remember if we went into all that detail. It's been a while, all right? With horizontal transformations, when they're in there with the x, x's lie. Okay, so if it says it is a minus, it's actually going to go to the right. Okay, if it says it is a plus, it's actually going to go to the left. Okay, x's lie. They do the opposite of what they say. Okay, that's why they're your x. Okay, all right. So we're going to talk about these horizontal transformations. Okay. And just remember, x's lie. So even though it says it's a plus something inside the parentheses, it's actually going to go to the left, to the negative side. The reason for that is because of this negative in our in our formula right here. So when we have a negative point or a negative x value for our vertex, then it's going to go to the negative. It's going to be a negative, which makes it positive. Okay. First things first, we want to start with our parent function. So I'm going to write our parent function over here on the side. I'm going to move this up some and put our parent function over here. I don't have a lot of room to write my graph or my table next to my graph over here. So I'm going to put it over here on the left. X, our f of x. We're going to start with our same -3, -2, -1, 0, 1, 2, 3, 9, 4, 1, 0, 1, 4, 9. If you watched the vertical transformations, you saw how it just shifts up and down. It just adds on to the f of x. With horizontal transformations, we have to do the adding and subtracting before we square, okay? So if you put these in your calculator, if you put x minus 4 all squared into your calculator and go look at your table, you will see some values, okay? So to get g of x, I'm going to take that -3, subtract 4, so I have -7, and then I'll square that. So -7 squared is a positive 49. -2 minus 4, we get -6, and then we're going to square that, so we get 36. Okay? -1 minus 4, we're going to get -5, and when we square that, we get 25. 0 minus 4, get -4, and then we square that and get 16. Okay? 1 minus 4 is -3, squared is 9. Fix my 6 here. 2 minus 4 is -2, squared is 4. 3 minus 3 minus 4 is -1. And then when we square that, we get 1. Now I'm going to add one more line here just so we have a 0. We get down to 0 here. 4, parent function is 16. Our g of x, when we do 4 minus 4, we get 0, and 0 squared is 0. Okay? So I'm going to tell you that is our vertex. If we want one more to 5, to -5, or sorry, positive 5, 5 minus 4 would be 1, and then 1 squared is 1. Okay? So let's start by graphing our parent function. Okay, so parent function. 1, 2, 3, and then 5, and then we're going to mirror it around our axis of symmetry, which happens to be our y-axis. Okay, so there's our f of x. All right, now for our transformation function. We have the values here that we can graph, and we can't do the -3, the -2, -1, or 0 because we just don't have those y values on our graph. So we're going to start at 1. Okay, when x is 1, y is 9. When x is 2, y is 4, which happens to be this point here. When x is 3, y is 1. When x is 4, y is 0. We only have half the graph, but remember we have an axis of symmetry. Okay? All that's happening is my entire vertex has been shifted to the right 4 units. Okay? And so because my axis of symmetry has been shifted 4 units, my vertex has been shifted 4 units, I can go ahead and mirror these points that I do know. Okay? Even if I don't have them on the table, I can mirror them to the other side. If you did happen to put them in your calculator, you would see the other points. Okay? And you can graph those points. So if I describe our transformation for this quadratic, and that is not a pretty. There we go. That's much better. I at least went through my points this time, sort of. And there's g of x. All right. So if we describe the transformation, the entire thing shifted to the left, to the right 4 units. Okay? I went to the right 4 units. Even this point went to the right 4 units. This went to the right 4 units. Okay, my vertex to the right 4 units. Okay, the whole parabola shifted to the right. So shift right 4 units. Okay. Our domain, as always, our domain is going to be x equals all real numbers. Okay, because it's just the equation. We don't have a situation attached. Now our range on our parent function is f of x greater than or equal to 0. On our new function, again, my minimum is at 0, so it's not going to change. Okay, my range is still g of x is greater than or equal to 0. Okay, so if it's just a horizontal transformation, if it's just moving left or right, it's not going to change your range. Okay? All right, so if we look at the next one, we're going to start with our parent function. We always want to graph in our parent function first. Okay? Unless it tells us that we're starting with something different, we want to graph our parent function because we want to know what we're starting with. Okay? All right. And I'm going to go ahead and do my table again. X and f of x. -3, -2, -1, 0, 1, 2, 3, 9, 4, 1, 0, 1, 4, 9. Okay, this time g of x, we're going to add 3. That's in our function notation form. It says f of x plus 3. Remember, f of x is x squared. When it says f of x plus 3 in the parentheses, that means that 3 is going in the parentheses with the x, and that whole thing is being squared. Okay? So this is the same as saying x plus 3 squared. All right. So if I take -3 plus 3, I get 0. And when I square 0, I get 0. If I take -2 plus 3, I get 1. And when I square 1, I get 1. Negative 1 plus 3, I get 2. And when I square 2, I get 4. Okay? 0 plus 3, I get 3. Squared is 9. 1 plus 3 is 4. Squared is 16. 2 plus 3 is 5. Squared is 25. And 3 plus 3 is 6. Squared is 36. Okay? So, this vertex is getting shifted. It's going to go to negative 3, 9. So 1, 2, 3, or sorry, negative 3, 0. Okay? And then all our other points, I've got this negative 2, 1. And then negative 1, 3. Or sorry, negative 1, 4. And then 0, 9. Okay? Again, we can only see half of it based on the points that we have written down. If you're looking at the table in your calculator, you can see more points. And you can see that this is our new axis of symmetry. And we can mirror points around that axis of symmetry. Okay? And we could do this because all of these points from our parent function just move to the right 3 units. Okay? I know. Why? It says plus 3. Why is it going to the right? Again, that plus 3 is really x minus negative 3. Okay? So x minus negative 3 becomes x plus 3. All right. So for our transformation, it shifted left 3. Our domain is still all real numbers. We're not going to change the domain unless we have a situation attached. The range, again, for our parent function is greater than or equal to 0. For our new g of x function, it is still greater than or equal to 0. Okay? All right. So far we talked about, in a previous video, vertical transformations where it moves up or down. Here we're talking about horizontal transformations where it's moving left or right. Let's put some together. Okay, so if we flip to the next page, okay, for 3AP, sorry, for regular on level, that is going to be page 12. For pre-AP, that is page 10. Okay? All right. Once again, we're going to start with our parent function. We're going to graph that parent function, f of x, okay, at 1, 0, 0, 0, 1, 1, 2, 4, and 3, 9, and mirror that to the negatives as well. All right, so there's our parent function. All right. We want to describe the different transformations that were applied. Now, here's the thing. With this transformation format, it actually tells us the new vertex. Okay? If I pull this number here and this here, this tells me my new vertex. But remember, x is lie, so, and that x minus 1 is part of, or the x minus is part of the formula. So my new vertex is actually going to be at 1, negative 4. Okay? So, at 1, negative 4, 1, 2, 3, 4, there's my new vertex. And my new axis of symmetry is going right through x equals 1. Okay? So I'm going to write that right here, x equals 1. There's my new axis of symmetry. All right. Let's finish graphing this. Okay, we're moving to the right, and then we're moving down. Absolutely, put this in the calculator. Get some points for you to graph. okay? If you want to start with your parent function and then mentally do the math, you can do that. I'm putting it down here just so you can see the difference in what happens, okay? And also because we've been doing the parent function all along, and we want to see what happens with the parent function, okay? So with this new function, when we put it into the calculator, go to g of x, well, under g of x, we're going to go to y equals, and we're going to put in x minus 1 all squared, and then minus 4. And just go look at your table, okay? So we're going to have 12, 5, 0, negative 3, negative 4, negative 3, 0, okay? And you notice the negative 3 and the 0 repeat, so our vertex is at 1, negative 4, which is what we have graphed over here. Okay, so let's go ahead and graph these points. Now I can't do the 12, I can't do the negative 3, 12, but I can do the rest of them. So negative 2, 5. Actually, I'm going to start from my vertex here. And we're going to go to 0, negative 3, and to 2, negative 3. And then at negative 1, 0, and at 3, 0. And then at negative 2, 5. So negative 2, 1, 2, 3, 4, 5. And that mirrors around my axis of symmetry. Okay, and that's all I could fit in there. And we'll just connect our points. Make a nice pretty little U shape for, as pretty as possible. This is h of x, not g of x. Okay, let me fix this. This is h of x. All right. So there is our new parabola, okay? For the changes to describe the transformation, it shifted to the right 1 and then down 4. Okay, right 1, down 4. Our domain, again, x is all real numbers. And for our range, f of x is greater than or equal to 0, and h of x is greater than or equal to 4. Sorry, negative 4. Okay? Because we had that vertical shift that pulled it down 4 units, we're going down 4. Okay? Our range is now at negative 4. All right. We have one more example to go over before you have your assignment. On this last example, given our parent function f of x equals x squared, describe the transformations applied and write the equation in vertex. Now, it's already graphed our g of x, okay? This one right here is g of x. Our parent function is not graphed on there. So if we go ahead and graph that on there, 4 and 9, 4 and 9. Okay, again, and I'm going to dash this just because we're just trying to show kind of what it looks like. Okay, where the parent function is. There's f of x. We're looking at comparisons, okay? So the new vertex is right here. Okay, there's our new vertex at negative 2, 3. Negative 2, 3. Okay? That tells us all we need to know about our transformation. It went to the right, to the left 2. It went to the negative side 2. Okay? So it shifted left 2, and then shifted up 3. Up 3. So for g of x, our new equation is g of x equals x plus 2 squared plus 3. Okay? Or we can write it as g of x equals f of x plus 2 plus 3. Okay? I know some of you are going, wait a minute, Ms. Johnson, why is it x plus 2? Okay? So off to the side, let me just remind you our g of x equation is going to be, for what we're talking about, just for the vertical and horizontal, it's x minus c squared plus d. Okay? So when we do a minus -2, it becomes a plus. Okay? So when I do a minus -2, if I put a minus 2 in for c, that minus -2 becomes a plus 2. All right, guys. If you are my on-level classes, your assignment is on pages 13 and 14 today. If you are my pre-AP classes, now that you have watched both videos, your assignment is on pages 11 and 12. Have a great day, guys, and I will see y'all later.